So today's video is going to be on this nice little device here. Everyone pretty much knows what it is. Anyone who's seen cartoons, at least, or the good ones from back in the day. So yes, it's a 50 cal blaster. Don't have much information other than it was made for the US engineers, apparently, and by Fidelity Electric Company, which is all what you see on here. All the hardware on the outside of it, so screws and everything, are brass. Inside it's all steel, basically, any of the pieces. Even the screws and the bolts are all made out of steel. This video, since I had to take it apart, this is its refurbished look to it. I didn't want to go overboard with it, I just wanted to clean it up a bit, so I decided I'd clean it all up inside. There's a little bit of rust, so I took care of that too. Anyways, I figured since I had it apart, I would show you guys how it worked. Pretty much, as everyone knows, you get the nice sound from it going up, and then when you push, you get the sound of a generator turning. It's done through gears, obviously. There's one big gear that transfers to a smaller one. Or should I say the rack and pinion transfers to a bigger gear, which transfers to a smaller one on the generator. That's just to increase the speed of it. And basically it keeps charging the generator as it goes down. It gets stronger and stronger, the magnetic field in the generator, which then obviously makes for more current and voltage, I guess, so energy in the generator. And as soon as you get to the bottom of the throw of this thing here, it makes contact with a switch, which then connects to these, which then connect to all your blasting caps. So 50 blasting caps in series is what it's rated for. And I'll basically take it apart now and show you guys the inside and how it actually runs through. It's basic, but it still basically works like the other one I've shown you in the other video, the 10 one, except instead of a twist, you got a plunger style. So I'll take it apart. I know that other YouTubers have basically done that. So Cody's Lab had a good video on it. Another guy did a good video even though he didn't have the blasting machine with him. Anyways, we'll go straight to that. I'll take it apart and I'll show you the basically everything that makes this thing work. Alright, so this here is the back view of this nice toy here. Just something to say, if you're going to take stuff apart like this, the screws should all be standard and everything, but I like to make a little template as to where they came out of. Much more important on old firearms than that. On wood, not so bad. It's just that if there is any difference in the screw, you might end up changing the shape of your actual screw holes. So I just like to put basically a piece of cardboard or something and have all the screws lined up how I took them off. And you mark it that way there, you don't have a problem with it. I know it sounds obvious, but a lot of people don't think about it. They just pile up the screws, and then when it comes time to put it back together again, they sort of screw themselves over. Basically how this thing works here, the inside. You've got all the mechanical parts visible from this side here. The only thing is you won't see the disconnect on here, which I'll show you when it's taken apart. So as you see, all the main components are visible. You've got your handle, which has a rack and pinion gear basically involved in it. And you saw how the clicking is on the other side of this thing here. So we'll go and actually do this. So when you pulled it up, nothing moved. And when you push it down, if I could hold it properly, everything's turning. And then that touches. So you see, it's released. Now it touched. So that's basically the way this thing works. Its reason for this gear is to just speed up the actual generator in there, and the rest is just done by the generator. So as it turns the generator, current's made, goes back into the generator to amplify, I guess you would say, by magnetizing the iron. I guess you would consider them almost electromagnets. They do have a little bit of magnetism at the beginning, because if not, your motor wouldn't, well, your generator wouldn't be able to make electricity without that initial little bit of magnetism. I guess it would be converting energy. Anyways, whatever you want to call it. And then as it gets to its maximum, because your speed that you're pushing the handle down is basically at its maximum, you then contact the side of this thing here. And this thing here touches, which then connects. You can't see the wires down there. When I take out the front, I might just take a picture of it to show. But the wires go, and it just basically goes from the wire here, connects to there, and goes through the two wires and blows up your caps. Very basic machine, interesting, historically interesting to have, because who doesn't want to have one of these? We've seen it in our cartoons all the time. We've seen it on movies, in movies. So it's a pretty cool little toy. I did test it, like I said. Lights up a 9-volt, lights up a full-size 120-volt light bulb very brightly. It lights up people very brightly too if you put your hand across the terminals. It's a nice feeling you get through it. One person said it feels more than 120 volts, because when he does it with 120 volts, he never had an issue with that. So it is something I probably wouldn't test putting my both hands across like that. But I'm sure somebody who knows more about these machines could tell us the full voltage that it puts out. I don't have an oscilloscope that's capable of doing that. I could try with my old one, but I don't think I'm going to get a proper reading off of it. So yeah, that's the basics of how this thing works. This piece here that you see at the bottom is just a bumper. It's almost like it's basically a piece of spring steel from the looks of it. So when you push down, it doesn't put a hole through the bottom of your piece of wood. It sort of prevents you from damaging stuff. At the bottom, just in front of my thumb here, that's your disconnect. I could show you it working, sort of, if I got the right light here. But as I pull up on this, you see it clicking past the gear. So the gear's turning and not actually locked onto the other gear, the bigger gear. But as soon as you push, it's in the opposite direction, and it causes the whole gear to turn. That would probably be a good wear point to worry about on these devices. Don't know, never really dealt with having one that's been worn out, obviously. Anyhow, as you push this thing in, it spins up, causes your generator to spin up, which puts electricity out through here. While that isn't connected, your electricity, instead of going out to here, so pushing it in, electricity is coming through here, going up these wires, going back in, basically wrapped around those ferromagnetic bars, which acts, obviously it puts a magnetic field into it, makes it a stronger magnet, which makes the current and voltage increase in this. basically it builds up on each cycle, I guess you would call it. Anyways, so it builds up, stronger magnets, stronger current output up to a certain point. Once it's at its maximum, which is basically by the time you've gone to the end of your stroke here, you now connect these two. So now the electricity being formed here, instead of going back in through has another path it could pass. So the electricity comes through here, goes through your switch, comes back in, and goes to here. So now these two are actually connected properly, so it goes through here. If that makes sense to you after the explanation. So you've got power coming out while the switch isn't on, or while it's an open switch, goes back, feeds itself, increases your power out, like the power on the actual generator. Once a switch hits, that power, instead of going back in, now is able to feed here, which lets it go to the caps, which sets them all off, and that's how your dynamite or whatever you were using to try to kill a roadrunner works. Alright, so I pulled apart the generator here, as you see. There's your rotating portion, the armature. And the part I wanted to show you about, what I was talking about before. In here, these are basically just iron pieces that hold a little bit of magnetism in them, and wrapped around that are the wires I was telling you about. So when the electricity comes in, it creates electromagnets basically on these, which strengthens the field.